Okay, this is part 2. So B will react via free radical substitution as well, because there's only boring bits and pieces now. That's right. And D, what's the mechanism for D with the halogen? And now a guess there. How will D react? Well, it will be addition, but you should say it's electrophilic addition. Okay. But it is a addition reaction. Well done. But it's electrophilic because they're after those electrons. All right. Next is this. Oh, this looks weird, but it's not. Doesn't look too hard in the end. So how are we going to do with this one? Figure that one out. What's that, do you reckon? Which can't undergo addition polymerization? It's pretty obvious if you know what you're looking for. Anyone there? Let's have a go. This colour. Okay. Okay, electrophilic addition. We'll do that, yeah, very soon. Okay, we've got 4 more questions to do, and then I'll definitely have a look at electrophilic addition. Okay. All right, now which one cannot undergo addition polymerization? Now, there's a thing that we have to know here. Addition polymerization requires a carbon-carbon double bond. Yeah, so the answer must be C. Piece of cake. Okay, well done. Okay, whoopsie daisy, wrong one. Whoops, what am I doing here? All right, now let's have a look at number 36. This one is quite hard. There's a lot here, I'm afraid. Even though it looks like a simple one. All right, which compound is the halogen substituted by the most rapidly? By aqueous hydroxide ions. Oh, do you know? Oh, it's a nasty one. All right, I'm going to tell you a couple of things we should know about this. Okay. Right, the first one is a CCl. The second one is a CI. Third one is a CCl. And the fourth one is a CI. Okay, so which is the longest bonds there? Well, the longest bonds are the weakest bonds, and the weakest bonds are the ones that are going to break the most easily. So the longest bonds are going to be the CI ones, this one and this one. So the answer's nothing to do with CCLs. It's one of the CI ones. Okay. Now, which one? Yeah, exactly. Now, the first thing we look at, dear, first, before we do that, is the halogen involved. I think that's the easiest way to do it. And then secondly, you look at which one's the tertiary and which one's the primary. This one is a tertiary. This one is a primary. Tertiaries, this falls apart. But primaries, you have to have something attack it first. So the quickest one is going to be the tertiary. Does that make sense? Yeah, I hope that makes sense. All right. Yeah, it's a nasty little question, that. I have my multiple choices are really good at making you understand chemistry. They really are. I think they're wonderful. So this one, make this one a bit smaller. There we are. Make it 100, and let's have a look at this one, which can be reduced to an aldehyde. Well, that's an easy one for us, Janet. Which one can you reduce to an aldehyde? Which one can you reduce? No, actually, it's not as easy as I thought. Which one can you reduce to an aldehyde? Okay, I'm going to do this. Do you want help with it, or shall I do it? Downward thumb if you want me to do it. Yeah, I'll do it. All right, so we start off with an alcohol. Okay, primary alcohol, secondary alcohol, and a tertiary alcohol. Primary alcohols get oxidized to aldehydes. Secondary alcohols get oxidized to ketones. And tertiary alcohols don't get oxidized at all. Primary alcohols get oxidized to carboxylic acids. Ketones don't get oxidized at all. Okay, so this direction is oxidation. And therefore, this direction must be reduction. And it wants which one can be reduced to an aldehyde. There's an aldehyde. The only thing that will reduce to an aldehyde is a carboxylic acid. So the answer is C. It's quite easy, really, but you've got to know your chemistry. Okay, excellent. Next is number 38. Oh, gosh. You're going to have to do this one. All right, this is a nice, straightforward one. Which of those show optical activity? Can you figure that one out? Which one has 4 different groups? Okay, I don't know the answer off the top of my head. I'll do it in a minute. Do we know which one has 4 different groups? D. 1, 2, 3. Yeah, I think so. Well done. Nice one. Let's have a look. What's wrong with this one? This one. 1, 2. What's wrong with A then? Let's draw it. Oh, I think. Oh, that's a nasty looking one. Only has 3. Yeah, I think there's a double bond there. Isn't that mean? Look at this. I think this one is this. BR. H. Yeah, isn't that mean? Yeah, but you're right. It only has 3. But there's a double bond there. I think that's a bit mean. But this one does look good. That looks like the optical one. Let's try and discover the 4 different groups. There's one group, methyl. Let's have this hydrogen is another group. The CH3 is another group. Yep, I think you're right, Janet. I'm 100% sure you're right. It's D. Well done. Okay, well done. But they can be tricky, but especially this one, because I didn't realize there was double bond there, but there is. Right? With closer inspection, there is a double bond. Okay, next one. Oh gosh, this one, you're on your own, Janet. You're going to have to do it yourself. All right, I'm horrible with these. We'll do it together. All right, let's have a look at this. Make it 100. Oh, right. Now, where are we? You're going to have to do it and tell me why it's the answer. Why aren't I good at these? Right, so what's the temperature change? Initial temperature is that. Final is that. So it's definitely 13. I get that. What's the answer there? And I'm going to cheat. I'm going to look at the answers because I don't know. I'm awful at these. This is 39, question 39. I've got an idea what I think it is, but I don't think I'm right. Oh, I am right. Oh, that was easy. Oh, if that's all it takes. Yeah, well done. It's these. So you add these, yeah? Whoa, what am I doing? You add them. Well done. Yep, you add these guys and you get that. Good for you. I didn't know that, but you did. Well, I kind of knew it, but I'd be lying, wouldn't I? Last one. I like these NMRs. Oh, God, they're not. You can't see it very well, though. Let's do that again. Oof. This is an NMR question. Let's make this a little bit bigger. Okay, which NMR, which is the NMR section of tetrasilane? Oh, that's quite easy. Oh, that's an easy one. Is that, you say it's D? Yeah, it's C. It's the one. It's got to be 1, hasn't it? At 0. It's the standard. Yeah, makes sense. I'm sure you know that makes sense. All right, now very, very quickly, we got like 5 minutes to do this. I'm going to get rid of all the other rubbish here, and now I'm going to do electrophilic addition. Now, this is where we get this. I'm going to do it as quick as I can. Okay, electrophilic addition. Okay, now on our course, it's how double bonds react. Okay, now why do electrophiles like this? Well, because there is electron-rich source there. There's lots of electrons there. So if you kind of think of it, there's an electron cloud there, and electrophiles want to grab that. Let's break up the word electrophile. Electro, that means negative charge. Negative charge. And phile, that means to like. So an electrophile likes a negative charge. So let's have a look at a simplest case. Ethene. And what am I going to add to ethene? I'm going to add a bromine. So let me get a nice bromine, and there's a bromine. Now, is the bromine molecule polar or non-polar? At the start, the bromine molecule is non-polar. Why is the bromine molecule non-polar? Why is that? Because there is no electronegativity difference between the bromines, obviously. So there is no electronegativity difference between the atoms. So it's non-polar. But as it creeps up to this area of negativeness here, the electrons on the bromine will be scared away to the other half of the molecule. So because this area is negative, okay, there's a lot of electrons there, the electrons in the bromine molecule will be scared away and they'll go to that side of the molecule, making this side positive. Now what we've done to the bromine molecule is we have induced a dipole. Okay, and now what's going to happen? Well, the electrons here can't resist it, and the electrons go out to capture this bromine because it's positive, and these electrons get scared away even more and go on there. So what do we get? We end up with this. There's a hydrogen. There's a hydrogen. Now the bromine is going to go on to one of these, and the other carbon is going to have a positive charge like that. Okay, there. Like that. And our bromine here has been chopped off. There it is. Now, but interestingly, it's grabbed on 2 electrons because the fission here, both electrons go one way. So the type of fission is what we call heterolytic fission. Okay, and so both electrons go onto the bromine. And when you have heterolytic fission, you get ions formed. Okay, so now what's the last part of the dance? Well, the last part of the dance is these electrons go and attack that positive center, and we end up with our product. Okay. Oops, that's wrong, isn't it? That should be a bromine. But there you go. And we get one bromine there, one bromine there. Come. And there's a bromine and a bromine. Okay, and it adds across the double bond. Does that all make sense, Janet? Excellent. So this whole mechanism is known as electrophilic addition. Why is it called electrophilic addition? Because the first thing, this guy here, the thing that attacked my double bond is called an electrophile. It gets made into an electrophile because we induce a dipole on it. Okay. Now, obviously, other electrophiles that we have to know in the course are that what do we add across the double bond? Well, we add bromine. That's an easy one. We can add chlorine. We can add HCl, and we can add HBr. And we can also add water. Okay, now these last 3 things I've said, these have a dipole already. Okay, so these will attack faster than the things without a dipole. So these 3 things, that one, and that one, they already have a dipole. These 2 things, when they get close to the double bond, there will be an induced dipole on those. Does that make sense? Make sense, Janet? Excellent stuff. Right, well done, dear. Let me go away from here. And I think we should all have a lesson on Friday. I'll post this. You tell me what you want to hear. what you want to do on Friday, and we'll do it. But I don't know, maybe a bit